Greetings, and are there folks remotely that are engaged, and is there a person going to be watching here? The reason I'm asking these things is that, and the reason I've asked you to come down closer, is that this is a little bit more like a discussion. At least I'd like it to be more like a class than like me just talking at people. So I would like it, it's totally appropriate if you have a question that you want to ask. And the only thing we do need to do is get a microphone to you so that the people in the remote settings can hear you. And I'm also going to encourage the people around the world here, if they have something they would like to ask, that they definitely contribute that through, and Allison will, and you just interrupt. You just, if somebody has asked something, just interrupt. Greetings. I'm going to try to give you a little introduction to system dynamics. At the end of it, you will not be experts. You'll have an idea of what people. Yeah, it's probably better if it's up there where I can see it. That's true. Now, actually, I don't go an hour and a half, right? I only go an hour, right? Okay, he's got it longer than that. Okay, you just, well, thanks. She just said she'll shut me up. You'll have an idea of how, of what the field is a little bit like and how some of us go about doing it. So let's begin. I'll give you a real fast systems perspective. I don't know if Gerald would say the same systems perspective, but lots of us think that when we read the newspaper and we read scholarly works and so on, we often see that we're focused on events and discrete decisions, isolated sorts of things. Various forces are coming together, and there's going to be a decision about whether we send drones into Syria. It's a decision. An event was Syria doing nasty things with chemical weapons, allegedly. And that's what really tends to attract our attention. A systems perspective tries to get underneath events. And if I can get my little clicker to go. Speak to me. All right, I need technical help. There we go. Are you okay? Okay. A system dynamics effort tries to get underneath the events by looking at patterns happening over time, rather than individual things that are popping up periodically. We're trying to hunt for a sort of underlying groundswell of dynamics that we would refer to. And we talk about them as patterns of behavior. We think of behavior not as the behavior of an individual, but the behavior of lots of things in a system. And underlying that, we think there's deep system structure that's actually giving rise to the pressures that are generating the behaviors that are underlying those events that we see. And a systems perspective at this level is sort of reactive. We see an event and we react with decisions, or we react with something else that's going to be another event. At this level, you have a chance, you're beginning to see patterns underlying things over time, and you have a chance to perhaps adapt. And at the system structure level, you get a chance to be creative, to be generative, to influence the forces that are eventually giving rise to the events and decisions that we see. So a systems perspective says that the leverage gets greater the further down towards system structure you can get. And that's a vision of a systems perspective. So I'll tell you how we try to get people into that deeper perspective. Before I do that, I should mention that there's a distancing that goes on in building system dynamics models. You're not watching individual events. You're actually deliberately backing off some so that you're beginning to blur discrete events and discrete decisions into patterns of behavior. And you're deliberately moving from a focus on an individual decision to a focus on what we call policy structure. 4 key patterns of thought. This is what characterizes the system dynamics approach. Dynamics, that is, it is system dynamics. We're looking at things over time. If you've got a problem, then you can wave your hand over time that's beginning to say, the reason I'm interested in this problem is because things are happening like this. Then you have a shot at saying, well, maybe system dynamics people could help. So we need to get good at dynamic thinking. And our simple tool that I mentioned the other day was graphs over time. The second great pattern of thought is causal thinking. It's not correlational. We're leaping out in bravery and asserting real influence among and between variables and concepts. So it's causal thinking. Eventually it feeds back around into feedback loops. It's thinking in stocks and flows, or accumulations, and if that's a kind of fuzzy term for you, we'll make it a lot clearer in a little bit. And the really big, powerful one is thinking endogenously, which has loosely been referred to as thinking as cause, a system as cause. Back when I was much younger, Pogo said, "We have met the enemy and he is us." That was actually on the first Earth Day poster in 1970. And the fault, dear Brutus, lies not in our stars, but in ourselves. That's an endogenous point of view. We'll say more about that. I love the word because it has so many letters. Dynamics. You all know about dynamics, but I'll just give you some examples. I gave you this the other day. This is the pattern of behavior, population behavior of all the mature cities in the United States, and I suspect Europe as well. They grow in a kind of S-shaped fashion, they saturate, and then they decline some, sometimes they bounce back. This, by the way, I'm giving you 3 slides now in 3 of those patterns of thought. So the first one was dynamics. This one is thinking causally, ultimately in having things feedback. Classic argument coming out of the social sciences. You'll recognize it perhaps. Prejudice tends to generate discrimination against the minority, which tends to limit opportunities for the minority, and that limits their achievements and causes the majority to think that the minority isn't as good as they are because the minority's achievements aren't as great, so it increases prejudice. Gunnar Myrdal in 1944, writing 1,500 pages on the American Dilemma, very famous book, became so impressed once he realized that that was the underlying mechanism. He essentially said, that loopy stuff is what social science should do. Now, Robert King Merton came along a little while later, and he said essentially the same thing in the very great article that we all know about, the self-fulfilling prophecy. So I'm going to add to this. The next part is not Merton or Myrdal, it's Richardson. I added aspirations of the minority and the minority's perception that their achievements aren't at their level of aspirations, and so that generates some pressures for the minority to achieve, and that presumably, if all goes well, might lead to greater achievements. And that loop actually is a kind of goal-seeking loop. That's what the B is for, and we'll explain a little bit more about that. That's a balancing loop. The R was a reinforcing loop because prejudice reinforced itself. The balancing loop essentially says the achievements aren't where we'd like them to be, we perceive the gap, we make major efforts to achieve more, and maybe that'll raise our achievements, and the goal of that loop is to make those achievements match with the aspirations. So a balancing loop is a goal-seeking loop. And I'll add one more loop just because it helps to tell the drama of this kind of story. There could be a link from the achievements of the minority to their aspirations. We haven't, for decades, 100 years, we've not been able to achieve. We will never be able to achieve, so our aspirations are low, so we will never perceive a serious gap, and we will never make efforts to achieve. That would be the despair version of that reinforcing loop. What I'm trying to suggest here, I have two things. One is I'm showing you pictures that involve words and arrows and reinforcing and balancing loops. I'll say a little bit more about that. But the other is you can say some pretty dramatic, serious, important things beginning to look at reinforcing and balancing tendencies in circular causality. The first idea was dynamics. The second idea was causal structure, feedback loops. The third idea is stocks and flows. Here's a simple example of stocks and flows in a gasoline crisis. So you heard me yesterday or the other day talk about the little boxes representing tubs and the pipes, they are pipes, representing the flow of gasoline from somewhere into the gas in stations, and people buy it and it becomes gas in their cars and they use it and it goes into the atmosphere or wherever. Normally, in your country and in my country, most of the gas is sitting in the gas stations. And there's some of it in cars. We're all driving it around, you know. And when you're the little fuel indicator in your car drops down to about a quarter full, you decide, I really think I ought to fill up. So you go fill up and you get more gas in cars. Now, what tends to happen in a gasoline crisis is we all get worried that there's not going to be enough gas, and I'm going to want to go from here to Melbourne, and I'm going to need to seriously fill up, or maybe just here to Sydney, and I'm going to have to seriously fill up. And as I'm riding, I may decide I want to fill up even when my tank is only half empty instead of when it's a quarter empty. And when that happens, gas moves so that it moves over into the cars that are riding around. We're carrying a lot more gas in our tanks than exist in the gas stations. And that happens, and I wish I could point to this. Actually, no, I guess I can't. They told me I couldn't. Okay. Yes, I can describe it. If you look at, can I walk over here? Is this okay? Desired gas per vehicle. This is how much gas, when do you want to fill up? Are you going to let it get a quarter or an eighth of the tank left and then fill up? Or are you going to want to fill up when it's just dropped maybe halfway? So when you perceive that gas is not very available, you're going to want more in your tank, so you will fill up earlier. And what that does is to increase the desired purchase rate, even though you're not going to use any more. And what that does is to move the gas from the stations into cars. And this solid loop that you see, station coverage, efforts to limit purchases, perceived availability, and so on, that loop is a reinforcing loop. And what it really does is when we get worried, we move gas from stations into our cars. And that actually exacerbates the crisis. And I don't think you can understand a gasoline crisis without understanding the stocks and flows that are involved. What we really do is you can have the shipment rate drop a tiny bit, and you can get this phenomenon and think that we're in deep trouble when we're not. There's more to say about that if we ended up with time at the end, because the policies we usually put in place to try to prevent this from happening are exactly the opposite of what we should. So if I get a chance, I'll come back to that. So more about dynamics. We use graphs over time to help us and our clients and anybody thinking about this sort of thing to define the problems that they're interested in. So we define problems in terms of graphs over time. We graph important variables. We graph historical data if we know it. We graph anticipated dynamics. If it's a problem, you probably have some thought about where it's going in the future. And that may worry you. That is, the anticipated dynamics may not look so good, and you may have preferred dynamics. You would sketch graphs of all of those. And notice that you don't have data about the future. You have thoughts about the future. So you're sketching graphs about the way you think it might happen, or you fear it might happen. So in fact, sketching graphs, you don't actually have to have the data. What you have to have is some sense of things going up and down, and using such graphs to help you define the problem and carry on the conversation with you and the others involved in the effort. And you would use those things to focus systems thinking and modeling. System dynamics folks, the minute you start talking with a system dynamics person and you're at dinner or whatever, the envelope will come out, and they won't draw the loops to start with. They'll draw graphs over time with you. So what's actually happening here? Unemployment in the United States up to 2012. You can see the short-term business cycle pretty vividly in there. You actually see some other dynamics. There's this apparent growth in the middle where sort of everything rises and then everything seems to be settling down toward the end. So there really is another cycle in there called the Kuznets cycle. Carbon emissions, we're worried about this sort of thing. This sort of graph helps people to focus on why we're worried about carbon emissions. This happens to be from 4 different sources. And you and I could sketch graphs of tons of things. You know how to do this. The thing you don't have yet is the knee-jerk reaction that says, the minute I start thinking about a problem, I ought to start drawing graphs over time. That's the only thing you need. System structure. There's a lot in what we would call system structure. There are accumulations, which I'll talk about, populations, resources, inventories. Causal structure, feedback loops. Delays are a part of system structure. Perceptions are a part of system structure. And by the way, if you think about it, you and I don't really know lots of things. We have perceptions, we have beliefs about them. For example, you and I don't know what the unemployment rate in Anchorage, Alaska is right now. We could probably make some guesses, but we don't know that. And we might not, if we wanted to know that, we might not be able to get that data, accurate data, for another month, because it takes that long for the data to be collected. So inevitably our perceptions are lagged to some degree, as perhaps biased as well. Pressures that come from perceptions are a part of system structure. And I deliberately spelled affects, meaning not effects, but affects. I mean emotions, I mean feelings about things, and irrationalities as well as rationalities. Those are part of system structure, and systems modelers doing a really good job looking at a tough problem will model those emotions, those rationalities, those irrationalities. That's part of system structure, and policies governing decisions are a part of system structure. So causal diagrams. If you and I were actually going to have a course for the next 12 weeks, we would stop at this particular point, and I'd sort of force you all to get really good at drawing causal diagrams, and there's some technical things to know. Here's an example. This is an imaginary example that I made up. I have the concept of the quality of life in a city, and I have 4 pressures or resources that are impinging upon that, and the people I allegedly talked to said that the crime rate influences the quality of life in the city, the number of retail outlets do, the number of absentee landlords influence it, and the number of neighborhood health clinics. Why did I pick those? They just happened to be in my mind at the time I was chatting about that. This is not intended to be exhaustive. Down at the bottom, I've got population and in-migration and out-migration. arrows indicate causal influence. And we assign polarities to the positive, to the causal links. This is the part that actually looks so simple, and the first 5 efforts you'll make at this, you'll mess up. Don't feel bad about that. I did. Everybody does. My students do. There are little puzzles that pop up. So, for example, I would like to put a plus sign on an arrow if it says, if the thing at the tail increases, then the thing at the head increases. You could say they're positively correlated. If the thing at the tail decreases, the thing at the head would also decrease, right? So from crime rate to quality of life, what sign would you put on that arrow? How many would say positive sign? How many would say negative sign? Okay? And the reasoning for the negative sign is that as the crime rate goes up, the quality of life in the city ought to go down. Now, somebody might say, well, it goes up because as the crime rate goes up, we're going to have more police on the streets, and that's going to make things better. But that's a different path. So if that happened in a conversation, you'd simply add that path. You wouldn't say the first path is wrong. You'd add that other path that tells a richer story. So yeah, I'd put a minus sign there. How about the number of retail outlets to the quality of city life? Come on, think like somebody who likes to buy shoes. Makes it better. Yes, absolutely. Okay. And the number of absentee landlords. These are people, I don't know if you have that in this country, but in our country we have rich folks who own apartment buildings who don't live there. And that has a tendency to have those buildings get more and more run down. So the more absentee landlords, I'm over in neighborhood health clinics, sorry. The more absentee landlords, the lower the quality of life would be the mental model of people drawing this picture. And the number of neighborhood health clinics, the higher the quality. And in-migration adds to population. Out-migration subtracts. Sometimes the plus and minus just means add and subtracts. Okay, got the idea? Well, then, if we were, going to all get good at this, I'd have a piece of paper for you all, and we'd sit there and put pluses and minuses on them for a while. But I don't have time to do that, and we'll hope that magic will happen, and you'll be able to do it on your own anyway. Feedback loop. So feedback, this, by the way, is Forrester's definition, comes from the original great work in the field called industrial dynamics. He said a feedback loop exists when decisions change the state of the system, changing conditions and information that influence future decisions. So the decisions create action that change the state of the system, that change our perceptions of things, and we base our decisions on our perceptions. Classic feedback loop. In fact, there isn't anything purposeful that you do in a day that's not based on a feedback loop. There's nothing purposeful that your government does that's not based on feedback loops. They are at the core of what we do. And there are 2 kinds. It's very nice. There are reinforcing loops and there's balancing loops. Aren't you feeling good that there's just only 2 things you have to know? Reinforcing loops tend to produce growth. They are destabilizing, they're accelerating, and they would have a positive number of even signs on those little causal links around the loop. And in the old days, we called them positive loops just because of the analogy to multiplying negative numbers. You multiply an even number of negative links, you get a positive. So the engineering disciplines called those positive loops, and system dynamics grew out of those engineering disciplines. In the modern day, we worry about people worrying about arithmetic and or positive being good. So we've turned to saying reinforcing loops. I'm unfortunately every once in a while unreconstructible, and I'll say a positive loop, and I feel very bad when I do that, and I would like to say reinforcing. Balancing loops tend to be counteracting. They're goal-seeking. We saw one that was goal-seeking a little bit ago. They tend to be stabilizing. They tend to have an odd number of negative links. Just when, just when you're multiplying the minus signs around the loop, if you had an odd number of the minus signs, you'd get a negative sign, you will get a balancing loop. Gerald?
That's just something I've never understood.
Oh, we need a... Well, I can also repeat his comment, but... Okay, go ahead.
That's just something I've never understood. It just seems magic. Why a reinforcing loop would have an even number and a balancing loop would have an odd number? Can you explain the
Yes,
theory
I
underlying
can.
it?
And in fact, the explanation is the stories that you would tell about from the signs in a loop. And so let me give an example of... Here are... I'm so glad you asked that question. Here's 3 examples of reinforcing loops. So the first one is classic births and population. Births add to population, right? So we'd put a plus sign. And the bigger the population, what happens to births? You get more births, yeah. Okay. So in fact, there's a plus sign on that link and a plus sign on this link. And the story that you would tell is, in some area of the world, births are adding to the population is growing, the babies grow up and become parents, and that still further adds to the population, which still increases the number of births per year. You can keep births per family the same, but you're going to get this reinforcing thing because you're getting more and more families. Of course, I left out deaths, right? In this tiny picture, we don't have deaths. But that's because we're just trying to emphasize what is a reinforcing loop here. So the story I'll get out of this is population growing because it contains the seeds of its own growth. By the way, that's what Malthus said. And lots of social scientists since Malthus have accused Malthus of being dead wrong, but Malthus actually was dead right. He's also dead. But he's dead right. He spoke about the naturally reinforcing tendency of population. The increase in one generation provides the power for a further increase in the next. That's almost a direct quote. Performance and motivation. I've already put the pluses on there. So the more motivated I am, the better I'll perform. The better I perform, the more motivated I'll perform. Of course, that doesn't go on forever. So this little loop is a kind of tiny abstraction of a much larger set of issues. The loop at the bottom, here's where we're going to get to Gerald's question much better. This loop actually it tries to describe what's going on in say, a city or a state with a number of businesses and taxes. So in my country, it would be a state, worried about state taxes. And you can start anywhere, but let's say you started at the tax rate. If the tax rate were to go up, what would happen to expected profitability of businesses? They'd go down. So we'd put a minus sign there, right? Oh, sorry. Oh, man, all right. I'll just talk it through first. And now, here's the trick. When you're assigning the pluses and minuses, always trace an increase in the tail. Not because that's the only way to do it, but because you're going to put the right sign on it if you do that. And you'll get confused if you don't. And I'll show you how that happens. But what if expected profitability of businesses goes up? The attractiveness of the area for businesses goes up. So we put a plus sign there. If the attractiveness for businesses go up, what happens to the number of businesses? Goes up. So we put a plus sign there. If the number of businesses go up, what happens to the tax base? It goes up. It's wonderful. If the tax base goes up, be careful here, because I have to add one more idea. If the tax base goes up, what could I do with the tax rate and still raise the same amount of money? I could lower it, right? So there's a minus sign there. So running around this loop are those links. That's what we just did. Now, here's trying to get at Gerald's question here. You can tell 2 stories from this reinforcing loop. Taxes are high in my state. Businesses expect their profitability to be low. So the attractiveness for businesses is low. They go together. So the number of private businesses is, well, businesses are probably leaving. It's probably going down. And if the number of private businesses go down, the tax base goes down. So what do I have to do to tax the tax rate? I have to raise it. So I raise it still further, and the profitability of businesses is now expected to be even lower. So the attractiveness is even lower, so I lose even more businesses, the tax base is disappearing, and I have to raise taxes even further. And that's why we would think of this as a reinforcing phenomenon. So it's the story that you get that tells you it's reinforcing. Now, if you're a math wonk, you just say, well, who cares about the story? It's got 2 minus signs. Come on, give me a break. It's positive. But that's not, nobody cares about, when you're talking with people about complex systems, they don't care about the arithmetic of signs, they care about the stories. So you really want to carry the stories. By the way, tell the story the other way. Let's say we lower the tax rate. Profitability of businesses would go up, attractiveness would go up, businesses would go up, the tax base would go up, and maybe we could lower the tax rate still further and have even more of a reinforcing effect. This loop, by the way, was implicit in the campaign promises of the Republican governor that challenged Mario Cuomo for the governorship of New York State 15 years ago. George Pataki said taxes are too high. And he came in and he lowered taxes. By the way, he also killed the money that supported the universities. But that's another story. Are we okay? Is that all right?
Yeah, no, you confirmed what I think, that the story is most important. I still don't get why 2 minuses equal I don't get the maths underpinning.
Okay, can I try to do that? The reason the 2 minuses make a plus is, think of the following logic. The tax base goes up, so the tax rate goes down. If the tax rate goes down, the expected profitability would go up. So if I drew a single arrow from tax base to expected profitability, it would be a plus arrow. The 2 minuses in the logic do exactly what the 2 minuses do in arithmetic. They reverse. Does that make sense? Yes, sir. Stephen. It is Stephen?
Yes.
Yeah.
George, the other way of explaining it is using same and opposite.
Yes, it's true, although there's reasons why I don't.
Okay.
But I'd rather not go there right now. But yes, same and opposite does help a lot. Yes, sir.
What puzzles me is that I think that the magnitude of the change doesn't change the story.
Right.
But I can't understand that in the same way that Gerald probably...
Well, I'll get to... The diagrams we're drawing right now are qualitative, not quantitative. And in the system dynamics world, there's lots of folks who think you can tell really good policy stories at a purely qualitative level. And there's other folks who say, no, you really got to quantify these things in order to be sure you're going in the right direction. I happen to be in the second camp, although I use quantitative maps to tell stories like that prejudice story, which I think is overwhelmingly powerful. I don't have to put numbers on it in order to get the power. So you're absolutely right. In order to say how much we have to quantify. And what we're doing right now is unquantified. Jane.
One of the ways I try to think about it, which might help Gerald, the answer to Gerald's question, is reinforcing loops can be thought of as either virtuous cycles or vicious cycles. So they're spiraling downwards or upwards. Mm-hmm. And you can think of a reinforcing loop as being consisting of all positives. But if you introduce one negative, it reverses the direction of it. The second negative reverses it back to the direction that it was going in. And so that gets back to the mathematical answer that George gave, which is 2 negatives cancel out a positive. So the first negative changes the direction, but the second negative brings it back to the direction it was already going in.
This is great. Now, I'm going to have to move on so that we get where we're supposed to go in 26 minutes. I just want to make sure that the people I'm looking at who are somewhere else are feeling free that they could ask a question, and if they do, it'll come through you. Okay, cool. Typical reinforcing behaviors, there's a link between the sign of the loop and what the loop is likely to do. Population and births tend to show exponential growth. Businesses and taxes I've actually built this little model of that loop, and I set it up so that it's accelerating decay. It's getting worse and worse and worse. Examples of counteracting or balancing loops. The first one I probably would, given my trip to the wig and pen the other night, I probably should refer to this as desired amount of beer in the glass, or ale. Comparing the amount of water in the glass to the amount you want, that'll tell you what fraction is filled. If not much is filled, you're going to pour. If the fraction filled comes up to 100%, you're going to eventually stop pouring, unless you've had too many of these. So that, we can put signs around that little guy, and you'll see that there's, in the loop itself, there's one minus sign, which says if the fraction filled is low, pouring ought to be high. Pouring will add to the water in the glass. The fraction of water, fraction filled will go up. And so we'll start getting closer to where the fraction filled is 1. So we'll probably slow up our pouring, if we're wise. And the water in the glass will still be rising, but rising slower. And eventually the fraction filled will be 1. And water in the glass will equal the desired amount. So this is a classic goal-seeking loop. And population and outmigration does a similar thing. Here population is subtracting, outmigration subtracting from population. But the more people you've got in your city, the more they're to outmigrate. That's why there's a plus sign there. The last one comes from a dynamic that occurs in northern New York State. We've got gypsy moths who eat fir trees. And there's a species of wasp that lays its eggs in gypsy moth nests. So it's a parasite for the gypsy moths. And we get predator-prey oscillations out of gypsy moths and wasps. So the behaviors for balancing loops can be pretty dramatic. Filling a glass is just kind of smooth. Population and emigration is exponential decay. And predator-prey interactions, I actually built a little model that did that. Shows oscillations. But there are subtleties. Not all word and arrow diagrams are alike. I was chatting with somebody, was it Allison, the other day at breakfast, and I mentioned this, and she said, "You should say that. You should talk about that." So I am. I got 3 word and arrow diagrams here, and all 3 are telling different stories. Now, you can stare at them for a little bit, and if this were a class and I was being properly professorial, I'd make you tell me what the differences are, but that may take too long. We've got the one about understandings of the system, we've got the one about carbon, and we've got the one about prejudice. Now, the one about understandings of the system, those arrows aren't causal arrows, because that's not the story you would tell. The story you would tell, this is actually a description that I drew and probably wrote in a text or whatever, about the system dynamics approach. We understand the system, we start with some understandings of the problem of the system, and then we conceptualize. So that arrow going from understandings to system conceptualization means and then. And then we build the beginnings of a model. That goes from system conceptualization to model formulation and testing. And then we test, and that helps us understand. So model formulation leads to understandings of the model. And then we reformulate or reconceptualize or revise our understandings and do some of all 3, and then we keep going. I don't want to go further in there, but the point is those arrows don't mean cause or pressure or anything like that. They just mean this happens and then that happens. You could do one of these for putting on your clothes in the morning, you know, and socks and shoes go in a certain order, right? Yeah. This one, these arrows don't mean cause either, because they actually mean flows. The words here are accumulations of carbon in our environment. They're stocks. And the arrows represent the flows or the channel of flow of carbon from one stock to another. So carbon in herbivores leads to carbon in carnivores because carnivores eat herbivores, right? And carbon in algae, plants, and trees goes into carbon in herbivores because those herbivores eat plants. Carbon in the soil becomes carbon in algae, plants, and trees because that's where they draw their nutrients from. And carbon in the atmosphere comes from herbivores and carnivores decaying. And there may be more stocks in this story, but the important thing is these are stocks. The arrows represent flows. And if you try to tell it as causal stories, you're just going to get confused. You're going to tell the wrong stories. It's not a causal diagram, it's a carbon cycle. And this is the only one that's a causal loop, and it tells this very compelling story about prejudice as a self-reinforcing phenomenon. So more about stocks and flows. Stocks are accumulations. They're increased by inflows, decreased by outflows. And every time we've had something that means add or subtract, we have a stock and flow structure. I had earlier before production, well, I had in-migration adds to population, out-migration subtracts from it. That's because population in the city is a stock, and we're adding and subtracting from it. Here I've got a business example, production and shipments affecting inventory. Now, we could spend some time talking about this, but I want to give one just dramatic example about thinking about stocks and flows. And I hope you'll agree with me when I'm through that a 7th grader or an 8th grader could follow what we're about to do. But in fact, in the research of my great colleague John Sterman at MIT, ordinary people in the world cannot think this through correctly. And he's got an article in Science that talks about it. So here's a model I have for you. On the left is my model of the economy. Yeah, okay, it's pretty small. There's a capital stock, which represents all kinds of things, and that generates economic activity, and some of that economic activity helps the capital stock to grow. So that's my model of the economy, and as you can tell, that's not the part I'm worried about. Economic activity has some carbon intensity to it. You know, we're using petroleum and other good coal. So economic activity tends to produce CO2. And CO2 produced tends to accumulate in the atmosphere. It actually accumulates differently in the lower and upper atmospheres, but I got one stock. And then I've got uptake of atmospheric, they call that sequestration actually, but I'll just use uptake. In other words, it gets pulled out of the atmosphere. And CO2, as we have been repeatedly told by the world, is a heat-trapping gas. So there's an influence from atmospheric CO2, it should be from the concentration, down to outgoing global heat energy. What would be the sign on that arrow? The more atmospheric CO2 I've got, what happens to outgoing heat energy? It goes down because it's a heat-trapping gas. So there's a minus sign on that. Now, I'm going to ask we're going to do a thought experiment. I'm going to imagine that through some magic, not by shutting down the economy, but probably by shutting down its capital intensity, sending it to 0. That's my thought experiment. So we will simply stop producing CO2 from economic activity. Now, we're going to carry this thought experiment all the way through. What I'm really interested in is what happens to global heat energy, because that's where temperature comes from. And the conclusion we're going to get there ought to surprise you. All right, so production goes to 0. Atmospheric CO2 is like water in a tub. The inflow has stopped. The outflow is the drain. It's still going on. So what does atmospheric CO2 do? It starts to drop, and right away, right? The minute I've gone to 0, it starts to drop. So that little corner occurs at the same time. Cool. So right at that moment, what happens to outgoing global heat energy? Well, it's now atmospheric CO2 has started to go down, so that means that heat energy can start to leave. And so it's going to start curving up, and that little curve occurs at the same place. Now this part's a little bit hard. You have to think like a kid in a bathtub. I want to know whether global heat energy is going up or down. It's going up if the inflow is greater than the outflow, if the faucet's turned on more than the drain. It's going down if the inflow's less than the outflow, right? This is just a tub, it's just a faucet. And if the inflow is the same as the outflow, then it's not changing at all, right? So in order to know what's happening to global heat energy, we have to know what's happening to incoming solar heat energy. But that's been constant. That hasn't been doing anything, roughly. But is it higher or lower than outgoing global heat energy? What's been happening to global temperature? It's been going up. So that means incoming solar heat energy has been greater than outgoing, right? So if I moved it over there so you could see it, it would look like that. I just slid it over. See the crossing point? So where incoming is greater than outgoing, global heat energy is going up. Where incoming is greater, sorry, how did I say this? where incoming is less than outgoing, then the heat energy is going to start going down. So the graph of heat energy looks like that. And the peak there is where those two little curves on outgoing global heat energy cross. Before that, it was rising. At the cross, it's an equilibrium. And beyond the crossing point, it is starting down. And notice what has to be true. That corner has to be later than when we shut down CO2. It has to be later. And if you ask anybody that you know about it, if we shut down CO2 production today, what would happen to global heat energy? What would happen to global temperature? They'd say, man, it would start going down. And it would start going down right away, and it cannot because of the simple bathtub physics of stocks and flows. And an 8th grader can understand this. By the way, I have trouble telling this story without this diagram. So you could say, I could say, even I mean, I've been thinking about stocks and flows for all of my professional life, but I need support in thinking through this sort of thing to realize that that peak in global heat energy and temperature has to occur after we manage to get CO2 under control. Got it? Cool? You're all supposed to nod and say, yes, that is cool. And Kyoto, of course, tried to say we were going to drop CO2 production. Is it going to do anything to atmospheric CO2? Well, this is a bathtub. You'd have to know how does it compare to the outflow. And scholars tell me that CO2 production would have to drop by about more than 50% to drop below the outflow. And that's not what Kyoto said would happen. So, in fact, Kyoto would say the CO2 is going to keep getting worse, and that would say that outgoing global heat energy will continue to go down, and that would say we'll continue to get warm. And it's straight up bathtub thinking. Are we okay? Great. You're doing wonderfully. At least you're nodding anyway. That makes me feel good. Now, I'm coming to the end. I think I want to flip this because I would like, just in honor of my friend Gabrielle, this is where we met over talking about tobacco. By the way, no one ever shows a diagram like that. You build it up. You never show anything like that, so forget I did that. It's very important to me to tell you about this endogenous point of view. And because I'm a scholar, I captured my idea here in a 2x2 matrix because every scholar needs a 2x2 matrix to become famous. You know, if you can't get your ideas into a 2x2 matrix, you know this. Yeah, it's got to be a 2x2 matrix in order to. So I'm thinking of the world. This is a variant of the Taylor-Russell diagram, if you know what that is. On the bottom here, I've got the true predominant state of affairs in some issue, like global warming, you could say. And the left side, exogenous, is global warming is coming about because of planetary motions and other kinds of stuff like that, and humans don't have anything to do with it. And the endogenous side says, no, humans are involved. And on the vertical axis, I have your predominant mode of analysis, or the way you're perceiving things. And again, I can chop it up into exogenous and endogenous. I can say I'm looking at it as an exogenous phenomenon, or I'm looking at it endogenously. And now I want to, and of course, this is an ideal state. It's never this clean cut. But to tell the nice story here, and to become famous with my 2x2 matrix, I've chopped it up in this simple way. So in the exogenous box, this is like, this is a true state of affairs. You're looking at the world the way it really is. The phenomenon is really driven outside somehow. Global warming really is a phenomenon of the eccentricity of the Earth's orbit and the tilt and a bunch of other kinds of things. And yeah, we've got these 100,000-year cycles, and humans don't have anything to do with it. So in that cell, you are accepting fate, predicting, and preparing. That's the way it is. And you know it, because you're seeing it correctly. You know, it could be this way in a marriage, you know. I'm feeling really bad because my spouse is always arguing with me. And in fact, you know, that is really the way it is. I'm not involved at all, you know. It's not my fault that she's always angry with me. So I just have to accept my fate, predict, prepare, and charge on. I'm glad you laughed, because I've told that before and people don't laugh. They get a little... All right. And now I've broken it again. Going back and forward? That was a great piece of advice. Yeah. Okay. In this box, you're wrong. This is like a type 1 or type 2 error. You are looking at the phenomenon as if it's endogenous, but it really is exogenous. I'm looking at global climate as if humans are really having a big impact, and in fact, they're not. That's what this box would say. So I'm striving for this endogenous understanding and leverage, because leverage comes from endogenous understanding. System is the cause, but I'm failing. So it's an error. Over here, this is nirvana. I'm looking at some phenomenon in the real world with an endogenous point of view, and it really is an endogenous point of view. Global climate really is being vastly influenced by human activity, and I'm looking at it that way, and we have a shot at achieving some understanding and leverage. This one is the worst cell of them all. The true state of affairs is really endogenous. That is, in my marriage, it really is us going back and forth, and we're both involved in all of the nastiness that we get involved with. But I'm taking an exogenous perspective, and I'll never understand it. Or global climate. Humans really are involved in climate dynamics. That really is an partly endogenous phenomenon, and we're taking an exogenous view, and in that view we're just simply going to be confused, misguided, and misguiding. So this cell is really an unhappy cell. This cell is a very happy cell. This cell is mixed. That is, I'm trying for understanding and leverage, taking an endogenous feedback point of view, but I'm failing because it's really predominantly being driven by forces outside my control. And this cell, you're correct, right? This is a correct cell. You're taking an exogenous point of view of an exogenous phenomenon, but I put actually I think the feeling here is worse than the one above it, because, and maybe this is just me, I'd like to be striving for that understanding. And I might even like to know that I'm just never going to get there, but I prefer having a feeling that I'm going to be able to have some leverage. We have 2 minutes and 25 seconds. This is a lightning fast example of system dynamics in practice. This is a group model building project done by a team from the University of Albany in Norway. We were talking to the Norwegians about offshore oil platforms. They were trying to move people off the platform onto the shore and still manage the pumping of oil out of the North Sea. So it was mixed consulting and theory building. We had 2 group model building workshops, and the first thing we did with people was to say, what do you hope about this and what do you fear? This is a very human process. And the greens are the hopes and the pinks are the fears. And we won't go through any of this, but some of it is hope about the methodology and some of it is hope about the project. And we don't constrain them. They get to say whatever they would like to say about, I hope the focus is on security. I hope Norsk Hydro learned something about system dynamics. You know, they could say anything they want. And they're also introducing each other. We do a power interest grid and ask them to tell us who the stakeholders are, and we post the stakeholders on the power interest grid. In the lower left is low interest, low influence. That's the crowd. In the upper left, that's low interest, high influence. That's the context setters. They don't much care about what you're doing, but they can do things that can really influence what's happening to you. On the lower right, that's high interest, low power. Those are the subjects. Whatever the powerful people do, the subjects have to deal with it. And in the upper right, those are the players. These are the people with high influence and high interest. And ideally, we would probably want to engage in a group model building effort with somebody from all those areas. And the dots on these, we asked the folks in the room to tell us who were we missing and who did we really have to have. We get them to sketch graphs over time and tell stories, and we cluster them on the wall. We get them to tell us if we had a really good, what kinds of policies are you really exploring here? What are you intrigued about doing? And then we sticky dot them for the ones that are important. But this actually helps us build a formal model, because you wouldn't want to build a formal model that's talking about things they're not interested in. You build a formal model about things they are interested in. And here's a tiny model capturing the problem dynamics. Capacity means oil platforms. Oh, I'm dead. All right, that's oil platforms. And then they've transitioned some to integrated operations. That's moving people on shore. And then they have mature capacity, and they've got risk. And they were worried about risk, and the goal was to lower the cost per barrel. This is actually the way that little model behaves. The risk is the gray curve, and that's the one they were worried about. The cost per barrel is the black curve, and that was the point of doing it. It would lower the cost per barrel. And so these things happen, and this is exactly what the problem description called for, but it's way too simplified. So we go through a long group model building process where we draw pictures on a big whiteboard. We build a formal model. You're not supposed to be able to see what that is. And the formal model does this sort of thing. And the left graphs are new knowledge in place. The middle graphs are new programs in place. And the right-hand graphs, which is the one I want you to look at, are the cost of incidents, that is, glitches, attacks, cyber attacks, or whatever. And the thing to notice is on that right-hand graph, there's one graph where the incidents don't rise as much as the others, and they come down much faster. So this simulation model says whatever produced that graph is important. We ought to understand what's there. And what's underneath it is the frequency of incidents and the severity. And it's the frequency that drops really quickly. So that policy dropped the frequency of incidents really fast. And that's the one you'd want to go back to Norsk Hydro and say, is that right? Have we found something important? So that's the one I'm talking about, those two little guys. When it works, why does it work? It works because we are engaging stakeholders in the process. We're using their mental models as well as all the formal tools that they could produce. We're trying to give them handles on complexity and and messes and wicked problems and whatever. The process tends to be aligning, because if the group starts out not seeing things the same way, they're all beginning to work with the same modeled environment, and they tend to converge somewhat over time. And building formal models, you have a chance to do refutable kinds of experiments. And someone could say, I think it would work better with this, and you can test it out. Or someone could say, I think that number's wrong by a factor of 10, and you go in and try it and discover it doesn't make any difference. And empowerment, that comes out of the endogenous point of view. We are working with stuff that's in the system, that's under our efforts, and so when it works, those are the reasons it works. Thank you very much. I've gone over.
Thanks, George. You can all see now why I'm such a fan of system dynamics. I'm really sorry we have to cut this short. We've got 10 minutes to have a quick break before the final debate session starts, and then we wrap up and then we're done. So please take a quick break. This is a great chance to catch George for some questions, but we will start promptly at 2:30.